In this exercise, we are going to assemble the toy helicopter that you see here. If you look at it, there's a number of components. You should be familiar with the fuselage from Lab 9. In addition to that part, we have servos. The little boxes around will highlight the servos. There's the fuselage part, which you're familiar with, another servo. The counterclockwise or the clockwise rotor, the frame that the rotor assembly attaches to, the adjustment link, which controls forward or rearward pitch of the helicopter, the tail fin, and the counterclockwise rotor. The scientific reason that you use counter-rotating propellers is for rotational stability. So the way this helicopter works is these two motors, or these two servos right here, run on gears. There's the one gear, there's the other gear. And if they run at the same speed, the two props counteract each other and the helicopter doesn't rotate. If you slow one down or speed one up, then the helicopter will turn left or right. And then this link here on this servo controls the pitch of the blades, which the weight of the helicopter actually causes it to lean forward or lean back. So by adjusting this servo, the controller can pitch the helicopter forward or back. So if you look at it right now, I'll take this link and I'll suppress that link in the assembly. And by doing that, I remove all the mating relations for the link, and I can pitch the rotor assembly forward or backward, which will allow the helicopter, the change in center of gravity will cause the helicopter to move forward or aft. It's slightly different than the way a normal helicopter works, but anyway, that's a summary of how this helicopter works. So there's no tail rotor required for it. If I bring that link back, if I go and unsuppress that link, the rotor assembly moves back into place. And we'll get started with creating this. So first off, you're going to go File or New Part. You want to do Assembly. Click OK. And then you can begin assembly. You're going to browse, and you're going to bring in the Lab 9 fuselage part. There's our fuselage. For the assembly, sketches aren't necessarily required. If you go up here to View, Hide All Types, that'll remove those sketches. So here's the base fuselage component of the helicopter. The next part we're going to bring in is the servo frame. So you click Insert Components, Browse, and you want to open up servo frame 3. Place this in the model. Once that's placed in the model, we'll start to add relations. So we'll go up here, mates. They're similar to your sketch relations, but they control one component attaching to another. So I click Mate. I grab this inner surface and this bearing surface here. If you notice, it would be hard to tell without being familiar with this assembly. This is backwards. I can change the mate alignment down at the bottom. Check OK. And then its left to right position I'm going to control by lining it up with this surface. Normally you'd have a thrust bearing that would do that. So now the servo frame is in place, and if you notice, I can rock that back and forth, so it's not fully constrained in that direction. The next part I'm going to add the counterclockwise rotor. That's the lower rotor of the rotor assembly. I'm going to place that in the assembly. Now, this shaft should run down through these supports. So these would be bearing locations in the assembly. So I'm going to select this shaft. I'll go up here, click Mate, click on that cylinder and align the two. So now the rotor's inside there. And then the next thing I'm going to do is align these two thrust faces, this one and this one, and that locates the rotor vertically. So now I can grab a hold of that cylinder and spin the rotor. So that's my rotor, and if you notice, the lofts that are used to create the blades are set up so that when this rotor rotates counterclockwise, it'll generate lift. If you notice, the fuselage has a small F in front of it. That means it's a fixed part. The servo frame has a minus sign. That means it's not fully constrained because I still want it to be able to rock back and forth, to show you that. And the rotor, well, in this assembly, I'm never going to constrain the rotor blades because I want to be able to swing them to make sure my tail fin will clear. So the next part I'm going to put in will be the other rotor. So this will be CW rotor. I'll place that rotor into the assembly, and if I hit Control and select this surface, that surface, and then go up and select Mate, SOLIDWORKS assumes they're two cylinders, so I want them to be concentric. I'll check OK. And now I'll select this surface and this top surface here. And SOLIDWORKS assumes that I want them to be coincident. I could make them parallel, which would keep them, but parallel is already redundant because these two cylinders being coincident or concentric would ensure that that's parallel. So now if you look, I have the rotor that goes the other direction. If I move these two over on top of each other, like that, one is going to produce lift when going counterclockwise, and the other produce lift going clockwise. So if any of you guys are interested in how these things work. Check OK. Now the next parts that I'm going to bring in my tail rotor or fin assembly in the back for the stabilizer for the helicopter when it's moving forward. Click Insert Components, Browse, and I'll bring that one up. So this is just a little fin. I was going to put a tail rotor in and then I didn't. Select that cylinder, go up to Mate, select this cylinder. Notice they're backwards, so you want to change the mate alignment. Check OK. And then select this cylinder and that cylinder. SOLIDWORKS already assumes you want them to be concentric. That's good. And then we're going to push this one into that one by a certain distance. So in order to do that, I'm going to select this surface and this surface. And now they're just edge on edge. But I can adjust that. If I click this distance setting here, I can flip the dimension, which goes too far. And then I want them to only be pushed in about a 1/4 inch. So now that fin has slid onto the back of the frame of the fuselage. If I pull my tail, or if I pull my rotor past it, you can see that my rotor assembly will clear. Both rotors will clear it. Okay, so now it's looking even more like a helicopter. The next thing I'm going to add, I'm going to go and I'm going to get my servo. Now there's 3 servos to control the to provide motivation for this helicopter, to be the motors for it. However, all of them are the same, so this is like your typical standardization of parts. Place this servo in, and if I zoom in on it and hit the control key, I can actually drag and make more servos. So that's taken care of. The next thing I'm going to do is I have these two bosses down on my servo frame. I'm going to zoom in, select the bolt hole that I want to line up with the bolt hole down here. Check OK. And then I'll select the other one. Check OK. Now if you notice, that's aligned as if it was on top of those bolt holes. So if I grab this part and drag it back and forth, see how it can go in? The last condition that I need, I'll click on the back surface of the servo and the front surface of, or the front face of that part. They both turn blue. Check OK. And that mates up my gears. All right. So now I've got these two other servos hanging out up here in outer space. And I'm going to do the same thing with the next servo. This one, I'll select that, come down here, zoom in, line it up with that bolt hole. I'm going to zoom in on these edges, click that surface, click the other inner surface. Those two become aligned. And then I'm going to select this face and this face. Sometimes you have to click on the faces twice, and that one becomes aligned. Now, if you look at from the back, you can see the one is lower than the other one. That's because the shaft for this rotor comes down through the center of the other rotor shaft to allow the motor to run it. Now, the pitch control for fore aft, for nose down, nose up, that's the last one we have to add. That one, there's two holes in the front of the assembly for it. So I'm going to select this edge, or this surface, sorry, and that surface. Bring those two together. Check OK. I'm going to zoom in. I'm going to get this one and this one. And check OK. And then I can slide. This might cause me some errors, because see how when I move the one, the other one's moving too? That's all right. I'm going to select this surface and the back surface of the servo. And now I have that servo in position. So now if I try to move that servo, the entire rotor assembly comes with it, and servo frame. The last part I'm going to bring in is just a little link to connect from this hole here to this tab on the fuselage, and that'll allow this servo to rotate back and forth and adjust the pitch of the rotor blades. So I'm going to go up, click Insert Components, Browse, and I'm going to grab the link part, open that up, place it in the model. And then I'll select one of these holes and this hole, line those up. And then I'll do the same with this hole and this hole. The last thing I need to do, because right now that's inside the servo and it's obviously not supposed to be, is zoom in on this side, select this surface and that surface. If we zoom back out, you can see our assembled helicopter. The next steps that you might do if this was your project, a control box and antenna that would connect to each of these wiring locations on the servos, and batteries. If I was designing this helicopter, I would hang the batteries on this portion of the fuselage here and a little bit to the forward to give more mass to the part that I'm rocking back and forth to control how this moves. So once you're at this point, go up and click Save. And you want to save this as Lab 10 Chopper assembly. And that's it. You can close out.